Hey guys, Jordan here, just going to talk you through how to register those underground scans. So you supplied me with some XYZ files, some OOT triangulations, and a DWG file of the CMS positions. So I'll import the XYZ files first. It's the hardest format. The file type of this is a bit messed up, so I just want to custom import it. This is your Optec data. So XYZ, it's a special Optec CMS sort of format, but honouring sort of XYZ coordinates. All of this information at the start we can't really use. So we need to start from line 25. So first thing I want to do is set our import data as a scan. So each file is a scan file. Data starts at line 25, so it ignores all that crap up the top. And I did notice that it threw an error because the very last line in this file starts with the letter E. I think it says end of file or end of format or something like that. So we just need to ignore any lines that start with the letter E. So you can see here it's ignoring those, but no big deal. I then want to tell it that this column is the X coordinate, followed by Y, Z, and if you want a bit of colouring on your CMS data, you can color by intensity, which is like a reflectivity reading from the instrument. If you're going to import these file types continuously, like again and again and again, different scans, maybe a couple of weeks' time you do the same sort of CMS scan and you get this same XYZ format, you can save this as a predefined format to import. And now it'll be in this list. So instead of going custom all the time, import CMS XYZ 2.0, which was the format in that file. So that's off and running. While we wait, let's grab those OOT files, import them, as well as the DWG. And everything is in meters. Computer's churning a little bit. I've got a couple other things going on in the background. We're getting there. So on screen here I've just got the origins as such, your coords out of the DXF. Now in the later versions of Studio, or unreleased Studio 6.0, there's a tool that can allow you to specify the origin for any scan file that's not necessarily a Maptek scan. So a Maptek scanner will automatically assign a origin, or the position of the instrument, for each scan taken. So unfortunately we can't do this in 5.1 easily. So I'm going to show you a different method. It's a little bit longer, I guess, and you double back a little bit, but in the end it gives you the same result. So here's our stope sands, as you can see, or CMS data, with the position of the boom shown quite clearly. So what I need to do is copy out the point position for each scan. So I'm just selecting it with point selection mode, hitting Control C to copy it, and Control V to paste it, and you can see it just pop up down in this list here. Next one, Control C, Control V. Next one, Control C, Control V. So I've got 5 points. Hide all except those points. And I'll also create a copy of those all in one file and rename that initial origins. So you can see that there. I've got one file with 5 points in that one file. Okay, these ones here get a little bit trickier. It helps if we rename them to match the CMS data that they actually came from. Otherwise, points 2, 3, 4, 5, it's a little confusing. So this one here is from up the top. So I can rename that one, rename, paste. So from level 9905, so this one, 98751. Just double checking. So number 3 is the same. 2. Down the bottom, number 1 is on the left, which is that one. Name 1, and that one. Oops. 2. Cool. Alrighty, so I've got 5 positions, a backup of those positions as points, which is pretty important, and all of my scans. So, global registration, it's also under register global, and I'm going to use the top scan as my base or reference, my fixed data. So everything might rotate a little bit away from these origins to match up with the orientation of the top scan. It's no big deal because we will correct that later. So you can see that angular drift right there, right? It's quite a large, sort of error. If I was to measure that, you know, 1.3 meters, it's not a small error. Alrighty, so top one scan is our fixed reference data, like so. Now I'll do the other 2 in blocks. Now what I need to do is lock these origins to my scan. So if my scan shifts and rotates, my origin comes along with it. So I'll load them in that top view as well. And then I just need to pair them together. So number 2, chain together. And this point here, I'm going to tell it to be associated data, which means it's not used in any calculation process. It's along for the ride as such. Same for that group. Number one, associated data. So if I load those 3 scans on screen, and only those 3, should be able to hit go, and you'll see a bit of a shift around to get them to match up. So it's not a great shift for these ones. I always run this a couple of times just to make sure that's alright. Just pretty good there. Alright, now I can add in the bottom 2. And you can see there's a fairly big rotational difference for those scans. The origin of them, it might be very well perfect, but the rotation or orientation of them is incorrect. So add those in. Same for the origin points. And pair them together just like we did the other ones. So chain 1 and 1 together. Chain 2 and 2 together. Select the point. You can actually see the icon is different as well. Associated and associated. Hit apply and we should see everything sort of dancing together. If I want to check the difference before and after, I can always hit undo and redo. It's a good idea to run this a couple of times just to make sure it's got a final fix. You might see it twitch around on screen, but you shouldn't see much movement at all after you've run it a couple of times. If you are, it means it's not able to get a solid fix. It might mean that there's not enough common data between the 2 data sets or 3 data sets, which is a problem. Like if we were only matching the bottom ones to the top one, there might not be enough overlapping data. Or point density becomes a bit of an issue as well. So that's all good. So these scans are now correct to each other. But if I look at the origin points that came along for the ride, so they're my corrected ones, load in my initials, and I'll just change the color of them so you can see. There's a bit of a rotation, so the top one should be exactly the same, which it is, and the bottom ones, or next one down, seem to be rotating, and worse as you go down, which is exactly what you were expecting, an angular propagation. So to fix that, we use register by matching point pairs. Our fixed tie points are our initial origins, which is your survey control as such, and our registered origins are our local tie points. So then I need to select everything I want to shift, which is our registered folder, and all of our other little points. And I'll just increase the tolerate area to 5 meters. Just make sure it definitely finds that large gap between points. I had a few issues running that at a lower number for some strange reason. So everything selected that I want to shift, nothing else, so not your drive surfaces. That's another thing I can do to check beforehand, is looking at this information here. Your drives are quite dramatically different. But hit apply. Everything gets snapped back to those initial origins. It gives you a little readout on what distance of error between them are. So up the top, we've got 20 mils difference, 8 mils, 33, 39, and 37, which is all, I guess, fairly sort of achievable. You know, the CMS accuracy is only going to be around that, and we're using that to alter scan positions as such, so that's about as good as you're going to get. So close that down. I'll now have a look at my scans. Look at these drives, and it's fairly well all the way around the outside of those drives, which is fantastic. Up the top, same thing. And I'll also compare it against my pre-registered scans as such, before registration. So you can see how much of a difference there is in noise there. It's much better all round, with the drive points fairly well the same, which is exactly what we're after. So although it's a bit of a mess doing this point registration, it still gets what you're after in about 10 to 15 minutes once you know exactly what you're doing. Once you sort of get in the groove and it's a process, you should be able to knock it out in less than 10. But yeah, any questions, do let me know. Cheers.